Thank you. My name is Jamie Mills. I'm a project manager with Pomerleau. And the project we were talking about, like you said, is the Alexander project. The project is located on downtown Halifax on Lower Water Street. Killam Apartment REIT is the developer. We are the construction manager for Killam. It is a 24-story, 240-unit luxury apartment building with a value of $50 million. We broke ground late August 2015 with the anticipated completion date of September 2017. Currently, we were performing the concrete structure on the second level. Our BIM team is SDMM, M&A, Michael Napier Architects, CBCL, and of course, Pomerleau. So the first presenter we have is Chris from SDM.
Thank you, Jamie. So we were brought onto this project as the survey consultant, and this small 35,000 square foot site, we were asked to collect the geospatial information like we normally would. The rest of the team, I guess the rest of the BIM team recognized that we had been engaged doing laser scanning projects. They also recognized that we were involved with doing scan to BIM projects, and it wasn't much for us to convince Killam to let us use laser scanning and modeling to represent this complex site. That was my Hendrix impression. Thank you very much. Particular site, of course, abutted by 3 streets, really steep elevation change. So clearly some updated survey ground information, and what we brought to the table was building information as well. We call it XBIM, existing conditions BIM, and existing conditions models of this adjacent brewery site, which is old. It's nothing straight, nothing's plumb. So this approach allowed us to hand over a data package, I guess, to the consultancy team, to the architects, and then in the end used by the contractors to verify existing site conditions with a high degree of confidence. Quote here from Jeff from CBCL is that the 2D drawing could never visually communicate the impact of such a dramatic grade or the elevations that we need to consider before tying in to such a historical building. Doing field measurements by hand is an exhaustive procedure and lacks accuracy. So we tried to remediate that. So we acquired existing reliable conditions documentation as accurate 3D point cloud information. We also provided 3D panoramic imagery to all the stakeholders. We host that on a dedicated website, share URLs. Everybody has access to the panoramic imagery, which is measurable. So that's your quick tape measure on the site without actually going to the site. Came to discover some very interesting uses of that information from Pomerleau, actually. Another quote here from Jeff. With SDMM's 3D model, we didn't have to start from scratch. It aided in our ability to complete the structural design that included an extensive 3-story foundation system and matching up to the new floor levels to the existing brewery market. So the existing brewery market, if you've ever been in there, has all kinds of different floor elevations and everything else. Jeff's team was tasked with, butting up into this, tying into this, so our information helped them immensely there. And I'm going to play a short little video that sort of summarizes, from our perspective anyway, how our information was acquired, computed, and handed over to the rest of the team. And do I have to do anything unique to make that play, David? Okay. So do I wave like, see that guy, he does it. So that's the point cloud information, of course, which you've seen before, for the site and for the building. From that information, produce a variety of 2D deliverables for everybody else. A topographic survey plan. We did this just as a throw-in, actually, some verticality or flatness for the walls of the building itself, just to aid in the structural team, the architectural team, to know what they're up against. And then this just demonstrates taking Michael Napier Architect's design intent model, aligning it with the site, and turning that over to the team. Great, thank you very much. There we go.
Good afternoon. My name is Robert Spierenberg, and I'm an architectural technician for Michael Napier Architecture. And I'm going to talk about the impact that BIM had on our architectural design for the Alexander. As an architectural firm, our main objective is to lead the client through the design process and bring their vision to fruition. In the past, this was accomplished using more traditional two-dimensional drawings. With the Alexander, we have the benefit of BIM at our disposal for the first time. The Alexander, being a rather complex building with several different floor plates and construction materials, seemed like a perfect chance for us to put BIM through its paces. Coupled with BIM-capable consultants, project managers, trades, would force us to use BIM to its greatest potential. In the earlier stages of the project, we used AutoCAD for schematic designs as layouts were fluid and we required quick turnaround of changes for the clients. Once general designs were a little more concrete, we began our journey with Revit. At first, the learning curve felt a little daunting, but the ease of transferring simple AutoCAD drawings to Revit made the transition nearly seamless for us. In order to maintain efficiency in the design process, we used SketchUp as a means of quickly playing with materials and forms in a more familiar 3D environment. Here's some views of our building looking down Lower Water Street from Bishop Street, and another one looking south. So yeah, in order to maintain the efficiency of design, we use SketchUp as a means of quickly playing with the materials and forms in a more familiar 3D environment. Once again, we were able to easily export the Revit model to ensure the most accurate representation of the building to put forth to the client for review. One of the benefits of working in a BIM three-dimensional environment is the ability to visually communicate a space to the client. With the Alexander, we are able to have objective discussions about the interiors, not as a flat representation, but as a fully fleshed out 360-degree view, such as our entry lobby, complete with potential furniture, layout, and finishes. As with any project, changes are a fact of life. How we deal with these changes can have a big effect on our relationship with our clients. With Revit, we are able to make the required changes in one view with the knowledge that these changes will translate throughout the rest of the building, reducing the chance of oversights and conflicts between drawings. This process allowed us to effect the changes quickly, neatly, and then move on. Coordination is always a major factor in any project, be it big or small. As I mentioned previously, having a team that is fully BIM capable allowed us to coordinate more effectively and communicate changes and ideas efficiently. This resolved potential issues that might not have been caught using only two-dimensional drawings. Changing the height of a drop ceiling, for instance, might seem trivial and therefore not discussed by the engineers, only to find out on site that there are several ventilation shafts that occupy the space halfway through construction. By coordinating and consolidating the 3D point cloud, the structural, mechanical, electrical, and architectural models, we have more of a chance of catching potential issues and clashes earlier and deal with them properly, keeping the client happy. With more and more manufacturers embracing BIM, it becomes easier for us, the architect, to ensure that the clients receive the most accurate information about the specified products to limit surprises and compromises after the fact. Currently, we're looking to work with manufacturers and suppliers with direct access to a Revit model to communicate our requirements and our expectations. Rather than relying on a separate manually created schedule or drawings, a manufacturer could take our model directly and understand our intentions and offer suggestions and solutions knowing full well they are working with the most up-to-date and accurate model. Based off that information, they could provide a better budget price and a more precise lead time, all of which adds overall efficiency to the project. During construction, we are finding the fully integrated model to be an invaluable asset when dealing with on-site questions and concerns. For example, by having a complete three-dimensional model to refer to, we are better equipped to deal with formwork, plumbing, or HVAC questions relating to areas that normally would not necessarily be represented clearly by a two-dimensional drawing. We understand that BIM is a completely different way of thinking over traditional methods. This, coupled with learning new software, has a tendency to scare people off. However, we believe that its many potential benefits makes BIM the future of our construction industry in Atlantic Canada. With more and more consultants, trades, and clients making the movement, now is the best time to consider it for the future projects. Thank you.
How's everybody doing today? Having a good time? My name is Mark Doyle, and I work with CBCL Limited. CBCL Limited is a multidiscipline engineering firm. We offer services in Revit using Revit structure, mechanical, electrical, and plumbing. And we're here today to talk about Navisworks and how we used it as our coordination software on the Alexander. The Alexander represents the first or the largest BIM project that our firm has done to date. It's the first time that we used Navisworks in such a capacity on this job. I want to take note with this model, and what you're seeing here, not so much the video in the front, but the image in the back there. You see the Navisworks model, and right alongside of it is the Servant Dunbrack model. And that's the point cloud. We found that point cloud very helpful at the beginning of the project when we were laying it out. It made it easy to match levels to the existing structure. It's a very handy tool. So what is Navisworks? How many people here use Navisworks on a regular basis? We got a couple. I was expecting the whole room, but yeah, it's good. It's a good turnout. When we think of Navisworks, what we tend to think here is clash detection. So much that all we really think that Navisworks does is clash detection. So today we're not going to talk about clash detection. We're going to talk about all the other great things that Navisworks does. So what is Navisworks? Navisworks is two things. It's a visualization software, and it's also a coordination software. When our engineers and users can easily visualize what happens inside a model, it makes it easy to adapt to change and make informed decisions about a design. Navisworks is also a project manager's toolbox. It gives a project manager access to tools that they never had before. Before, we used to use 2D drawings, and trying to compare them to find challenges in the design was very challenging, but now we have a model. And here you see, this is our Navisworks model for the project, and one thing that we can do is strip away objects within the model. So we've stripped away the entire architectural model, and right now all you see is the engineering services that are provided within this model. As you see, it's very colorful. And this is a lean technique that we use where we use color to visually identify objects within our model. It's very handy. Now you can look at the model and know exactly what you're looking at, as opposed to if they were all just gray and you're looking at that in your model. Very hard to pick out. Navisworks also gives us the ability to measure in a 3D environment. This is something that is not easily achieved in Revit. Sure, you can do it, but it requires locking views, cutting sections, and whatnot. So it's pretty handy. Something very interesting to note with our picture here is in all of our units, we made all the bulkheads semi-transparent. This was fantastic in our coordination meetings because we could go look at a unit, but then see what's in behind the walls. And because everything's colored, we can visually see what it is and identify if it's a problem or not. Beyond geometry, Navisworks also gives us the information, or the eye in BIM, letting us see deeper into the model. So it's not just shapes, we get that information component within the model. Moving forward, I want to focus on the mechanical penthouse. So this is levels 21 and 22 of the Alexander. And this is a really tight mechanical room. a very condensed space, very congested. It had sloped exterior walls and only a 10-foot ceiling height. And so one of the things that our mechanical engineers did was raise all the ducts in that area up to the ceiling. And in the next image, you'll see it gives you the illusion that there's a lot of space within this mechanical room. So what you're seeing here is the mechanical room. We've removed the curtain wall panels and just left the mullions so you get an idea of what the space is there. But that space is a very well-organized space because our team is able to get in there with the weekly Navisworks model and see what's happening in the model in real time. It enables us to adapt to change and make quick decisions on the fly. The blue boxes there represent our electrical area. Our electrical team have been using this Navisworks model very intensely to explore different design options as changes happen. So I want to bring things to a close here with one of my favorite quotes. It's by William Pollard. He said that learning and innovation go hand in hand. The arrogance of success is to think that what you did yesterday will be sufficient for tomorrow. He said this over 100 years ago, and I believe it still is true today. CBCL Limited feels that BIM is the future. It helps with a better design, a well-coordinated design, as compared to legacy systems like 2D sheets. So why not BIM? And why not Navisworks? Thank you.
Hello everybody, my name is Magdalena Ordyniec and I'm a BIM VDC manager in Ontario and Atlantic Canada at Pomerleau. Let's move forward. There is one more slide that's missing. No idea why, but that's okay. Pomerleau is a general contracting and construction management company that also specializes in BIM and BIM implementation and virtual design and construction. We offer a full spectrum of services from pre-construction to the commissioning of building systems, delivering medium and large-scale institutional, commercial, industrial, residential, and civil engineering projects. Pomerleau has 11 offices, including St. John's and Halifax in Atlantic Canada. And currently, 50 of the buildings projects across all provinces are using BIM in many different phases. We have started BIM implementation 5 years ago with 3D modeling, testing how BIM can help our organization, and buying and hardware and software just for a few team members. Right now, we have over 30 BIM specialists in the company. Over the years, our BIM expertise advanced with every new project and with every new tool and the workflow. We have learned how BIM can help to execute projects faster, to achieve cost savings, and improve quality of the project. Also, the clients appreciate the results of our BIM and integrated project delivery approach, which often leads to repeat and referral business. This scheme shows all the BIM uses that we currently have at Pomerleau. On the Alexander project, we utilize many of these tools and methods, starting with the models created by our awesome designers that are gradually updated to reflect the construction conditions and help us with the project execution. During this iterative process, we obtain intelligent, coordinated 3D models that will be used at the end of construction for the as-built documentation. Following our BIM strategy and IPD approach, the construction team and the teams of architects and engineers collaboratively reuse and share their models during the overlap design and construction phases. This helps to streamline communication, to enhance design coordination, reduce risk, and improve quality. The intelligent 3D models help to exchange information. They are used to export data for quantifications, to review constructability, of course, avoid clashes and reduce errors in the field. So let's see some of the examples. As mentioned before, Autodesk Revit is being used on the Alexander project. And for the purpose of better productivity and quality, Pomerleau has developed a plugin to help engineers to semi-automatically populate over 50 different apartment layouts from the linked architectural model in the mechanical and electrical model. This plugin saved a lot of time that would have been spent on setting the views manually. So in just a few quick steps, it can accurately transfer hundreds of plan views between disciplines. It means time savings, of course. Another plugin that we have developed is the estimation plugin. This is another Revit plugin, but it links different cost estimation software that we're currently using in the company. It's used for internal extraction of concrete and formwork quantities from the model, and it automatically places all the values in the schedules in Revit. So the plugin first applies extra parameters to each and every element in the model, and then it combines the values in those schedules, and from there, the accurate quantities can be easily and quickly exported to Excel and used for estimation and cost control. This is another great time and cost saving tool that we have on this project. Currently, Pomerleau is using Navisworks for preliminary clash detection to communicate issues with the designers, but the following tendering process we plan to utilize Autodesk Glue for mobile coordination on site. Thanks to the clash detection tools, conflicts between disciplines can be resolved in the model weeks before the work is scheduled on site. In other words, thanks to BIM, we can forecast future problems and avoid them in advance. Coordinated models and drawings are then used by workers on site to finish their tasks without delays. There is no need to submit RFIs and change orders, etc. Better quality, that's what we get. Another technological tools that I wanted to show you today are the Smart Use. You can see our superintendent using the Smart Use board on site. It gives us access to updated drawings and linked specifications, details, and pictures. It's a great reference during the meeting, and we can bring all the documentation with us on site on the mobile devices, such as iPad and Microsoft Surface. Another great tool is the BIM 360 Glue. It gives us mobile access to the 3D BIM model on site. We use it for multidisciplinary coordination. We can create markups and send emails directly from the walking on the site. We can access all the object properties and measure the distances, and we also use it for the progress monitoring and the quality control on site. So having the overview of all the useful BIM and VDC applications, let's summarize what are the potential BIM benefits for the Alexander project. Based on our experience with the proper tracking and estimation of the resolved issues, we will have enough data to calculate how much time and cost we have saved thanks to the BIM technology. What we can say for sure right now is that the building information will be stored in the models, and it will continue to accumulate through all the phases of the project. BIM will compensate the loss of time and money that usually happens on project executed the traditional way during transfer of inaccurate 2D documentation from one phase to the other. In conclusion, thanks to BIM, we can access the information faster during design and construction phase, which means time savings. We can better control the quantities and cost of the material, which means the cost savings. We can produce better coordinated and accurate as-built documentation for the client, which means better quality. And finally, BIM models can be used after construction for operations and maintenance of the building, serving as a great source of information for the facility management. And that's why the great rock band here is using BIM. Thank you very much.
Question? Thank you very much. Yeah, please.
Sorry, I forget your name, the representative from MNA.
Robert Spearberg?
So I don't think anybody really disputes the benefits of the integrated design process and programs like Revit and stuff. Where I find a lot of people are tentative is when it comes down to the technical design level in using programs like Revit. Now, what would you say to somebody who is tentative to use the program on a technical detail level and producing the construction documents? Or would you say, I've tried that, doesn't work, sticking to AutoCAD?
We've actually heard lots of stories about people who like the idea of using BIM for most of the project, but when it comes down to detailing, they do revert back to AutoCAD. I found it quite the opposite. I couldn't wait to detail in BIM, mostly because of the fact that it's very easy to use the information that's already in the model to decide how details are going to come together. For example, you can easily do a section cut through any part of the model at any time and know that that's an accurate situation, and you know the parameters that you have to fit your detail components into. A lot of the detail components are either already built into the either Revit or ArchiCAD, or there's also lots of information online where you can get more detailed components that have information in them based off of manufacturers or other products that you can find. So by using Revit in our case for the detailing, we were able to produce the details a lot faster than we probably would have in AutoCAD, and then tagging it or all the annotations for it also became a lot easier, because once again, if you changed one item in one detail and you knew that it was going to translate throughout the project, you could easily do that using Revit as opposed to AutoCAD DWG details. But you can also take details that you've already done typically and brought them back into Revit as well. So it's easier either way.
Okay, perfect, thank you.
Great question. One of the things I used to hear all the time in my previous role as an Autodesk software distributor from architects who were first exposed to the use of these tools, that a lot of architects will express that a part of their client value is in their drawings, the art and science behind their drawings. And yes, very early on, these BIM tools weren't as good at detailing, right? And I'd hear architects say, and rightfully so, that one of the things our clients like about us is our drawings are so well done, they're well detailed, and so on and so forth. I've been out of that space for quite some time now, so it would be really curious to hear from others, just to that very point, what's the general feeling that these 3D tools that are a part of a BIM process, have they evolved to the point, have different processes and workflows evolved to the point where I can create a construction drawings from my BIM model with confidence? So I'd be really keen to hear more from the floor on that one after the next presentation. So thank you very much, everybody. I hope that was very insightful, and actually look forward to maybe getting an update in about a year or two when that project is finished.
Thank you very much.